have only one dimension.
Star schema.
In star schema, the fact table having on the dimensions like
First of all, okay, like what is a fact and what are dimensions?
fact table facts are basically the measures
Okay,
which define the
okay.
mm,
Some numbers for the
measures of
business
business.
mainly. And you
Yes.
can, and also like you can perform some operations like sum, average, or multiplication, some aggregation functions you can do on that to arrive like to get the complete
Yes.
cells you can sum up. So for dimensions you can't sum up, like that also is the main difference. So dimensions are like
Okay.
descriptive things which says about
Yeah.
the
More
facts.
specific information about
Yes,
fact table. Yeah.
like that would be a key insert in the fact table, and for that key insert like some what is this product id would be the key insert in fact table along with the measures. And this product again, there would be a dimension table attached to it, and for that product, that attributes again you will capture in the dimension table. It would be in that way.
Mm.
So now what is
Okay.
star schema?
We have only one fact table,
Okay.
and in Snowflake schema there are having sub dimensions
Mm.
are there in.
In star schema, you would be having a fact table in the center, and around it,
Mm.
the dimension tables would be there, and this fact table would be connected to the dimension tables.
Dimensions.
So it looks like the structure looks like a star. So we call that as
Star.
a star schema. And snowflake
Yes.
schema,
Snowflake schema. Mm. In that
snowflake schema, like I think like your audio is
schema, the
disturbing.
dimensions have
Your audio is like it's like not coming. It was coming
yeah,
like cut cut.
I have network
Some issue.
problem.
Okay, okay. In the snowflake schema, you would be having a fact table at the center again, and that fact table would be surrounded by dimension table. That dimension table would be connected to the fact table, and for that dimension, there would be again subdimension tables, so that like some object or attribute which was present in dimension table, again it would be divided means like that object or key which was present in dimension table would be taken to the subdimension table, and for that key again you capture the attributes.
Yes.
So that is called snowflake schema. The next one, what is the next one?
Galaxy.
Okay.
Galaxy, the
Ah,
combination of snowflake and star.
no, wrong. It's not a combination. If you have more than one fact table, like two fact tables I have explained yesterday, right? So you are having only one fact table, then that would be like star schema or snowflake schema. If you are having
Yes.
more than one fact table, then that we say as galaxy schema. Okay. So now we will move on to next concept.
The dimension will which is shared by both fact table.
Yes, are called confirmed dimension. Okay, so we will move on to the today's class now.
Called that perfect dimensions.
Yeah, confirmed dimensions. See again today, like OLAP operations, OLAP cube operations also you can say. We have discussed the OLAP cube, right? So there are some operations we can do on that. That we call as OLAP operation. Those operations are roll up, drill down, slice, dice, and pivot. So these are different OLAP operations. We have discussed like what is a OLAP cube, right? What was the OLAP cube? What is OLAP cube? Mayur?
OLAP cube.
Yes, we have discussed, right? OLAP cube. I think like not last class, before that class we have discussed what is a OLAP cube.
Mhm. I didn't remember.
Multi-dimensional data, right? Representing the data in X, Y, Z, like multi-dimensional. Multi-dimensional data, if we are representing, that we call as a OLAP cube. So I have also drawn and shown you, right?
Okay.
What is OLAP cube? Suppose Here you are having only, you can time means like you can say like quarter or month, like anything you can take, and your sales numbers you wanted to describe on x-axis. Then that would be only 2 dimension, right? If you want to see another dimension or like multi-dimension, you can capture the data. So you wanted to capture city as well. Okay. This is something that you are capturing the data in a multi-dimensional way. Understood? What is a OLAP cube? The data, if you are representing in a multi-dimensional way, then that you can say as a OLAP cube.
Okay.
This concept like would be applied in general, you think? Like till now, what we have discussed based on that, I was asking this question. I think like I haven't told this. So you have discussed like database and data warehouse, right? Where this OLAP concept applies. Just think generally. In a database it would apply, or in a data warehouse it would apply.
Database.
In data warehouse it applies actually,
Acha.
because you are having all the data in a multi-dimensional way here. In database, what you are having? In database, you are having like what is required to run for that particular stores. If you are having 10 stores, you may have like 10 different individual databases for that, for each store to run the operations. If you are having in different cities, then at every place you would be having some database, right? But in data warehouse, you are clubbing all the things, and you are having a third dimension of the city for your data with respect to cities. So this clubbing concept or representing the data in a multi-dimensional way is called a cube, and this concept applies to data warehouse. For database, OLTP applies, online transactional processing. So that concept applies to database. Are you clear? Hello,
Hello.
are you clear?
Yes.
Okay. So now we move on to the operations of OLAP. First is roll up. Roll up is like aggregating one of the dimension or introducing a new dimension, you can say. So here you think you are having different places in Hyderabad. in the Z dimension. So for your store, you think like it was in India and US. So your stores in India are in Amirpet and Kokatpalli, you think, and your store, your brand, like one of the store is in Chicago, you think. So what these two comes under India. Just remove this. Wait, I will say other. I will just keep states. That would be better. Telangana and Uttar Pradesh, you think. Rolling up is the concept of aggregating the dimensions and getting the data. So if you see Telangana and Uttar Pradesh are in India, so I will club or aggregate these two and make the data to India and US. So then the how the cube looks like. So here there are three set of data, right, in the Z dimension. So now I was bringing that to 2 because I was aggregating these two as India, and there is only one dimension here, so that I will make it to US. And all the other data would be there in that way. Only in the Z dimension, I was aggregating to reduce the data. We call this operation as roll-up operation. Are you clear on this? What we call as a roll-up? Hello? Yes or no? Mayur, are you clear?
Yes, Surya.
Okay. Drill down is the reverse of roll-up operation. We will consider here. In the time initially you have like first quarter, second quarter, third quarter, fourth quarter. So these are the data you are capturing in time dimension. The drill down operation is here you are having only 4 data or 4 rows you are like capturing first, second, third and fourth. If you want to drill down this 4, I will split into 12. Like I can split into 12 means like I will split into January, February, March, April, May, June as second quarter. Third quarter is July, August, September. And fourth quarter is October, November, December. So here what I was doing, I was splitting first quarter into 3, second quarter again into 3, and third quarter into 3, and fourth quarter into 3. This type of operation we say as drill down. Are you clear on drill down? It is exactly reverse of roll up. Yes or no? Just type and we will move on to next. Okay. The next operation is slicing. Slicing is an operation of getting a part of the data with respect to one dimension. So only this part, only X and Y I will capture for this particular one. Then the data looks how it looks like is a two-dimensional. This would be sales and this would be time. This is the concept of slice. Slice is you are getting the data from the OLAP cube with respect to a particular dimension. So in the slice, like when you are cutting or bringing the data from the OLAP cube, it looks like this way, and you will be having with respect to sales you are getting, then with respect to time and sales would be there. So this operation we call as slice. Are you clear on the slice operation? So these are all theory, you won't do practically, but just I was telling. Next is dice. Dice operation is a subcube from the main OLAP cube, you can see. So here all the dimensions what is there in your OLAP cube, it would be there. So you are having sales, time and city. It is like similar representation of the your OLAP cube. In slice operation, you would be having with respect to one dimension like sales and time. And the third dimension also if we capture, then that is called a dice operation. Then dice operation means you will get total this part you say. So you are getting this part if you see in this cube. This is a dice operation. Are you clear on this? What is the difference between slice and dice? Yes or no? Okay, good. And the last one is pivot. Pivot or pivot function is exchanging the dimension from x-axis to y-axis and y-axis to z-axis, sorry, y-axis to x-axis or y-axis to z-axis and z-axis to y-axis, like interchanging the dimension from one axis to another we call as pivot operation. Pivot operation is interchanging the axis. For interchanging from city to time and time to city, you are just interchanging the axis or here to here or here to here. So that is called a pivot operation. Are you clear on this? Yes or no? Okay. So these are the 5 different OLAP operations. The next is normalization and denormalization. Normalization is splitting a table into multiple tables to reduce the redundancy of data we call normalization. And denormalization is like combining multiple tables into a single table we call as denormalization. If we are dividing like in normalization, we are dividing a table into multiple tables. So what you can do is like that data redundancy can be reduced and inconsistency of the data can be reduced. So like obviously you can achieve good data integrity in normalization. If for the denormalization technique, you are combining like multiple tables into a single table. If you have a single table, what would be the advantage? You can retrieve the data faster. And normalization is generally used in OLTP system. And denormalization is generally used in OLAP system. Here, and also like normalization, you are splitting the table into multiple tables, right? So number of tables and joins increases. Denormalization reduces the number of tables and also joins, because you are combining multiple tables into a single table. In the denormalization, as the redundancy is increasing and inconsistent data will be coming more when you are denormalizing, then the obviously the disk space is wasted and more space it takes. In the normalization process, you are reducing the redundant data. So obviously the size would be lesser and you will consume less disk space. Normally, and also normalization is used when you require a faster process, and denormalization you use when you require a faster search. That is the main difference between normalization and denormalization. In OLAP, we require a faster search operations. So that's why we use in OLAP denormalization. In normalization, in OLTP, we require fast process as we are using for operational purpose. So there we use normalization concept. Understood? Okay. Like the class will close in another 1 minute. Then we can meet in tomorrow. Like all the data warehouse concepts are covered. So you just go through the things, and if anything is unclear, the next class, like I will just completely dedicated to doubts, your doubts on the data warehouse. So you go through all the concepts what I have discussed in data warehouse, and you can ask if you don't understand any concept tomorrow. Okay. Okay. Thank you guys. Bye.